In this example, we're trying to find the area between the graph of the function y equals x squared minus 9 and y equals 7. Now in this case, we're not given any limits or any boundaries that we're looking in between for our interval. So in this case, what I need to know is where do these two intersect? So I'm going to do that by setting these two equations equal to each other. Okay? I'm going to take x squared minus 9 and set that equal to 7. And then I'm going to solve for x. So by adding 9 to both sides, I get that x squared is equal to 16, which tells me that x is equal to either positive 4 or negative 4. Okay? So these are the places where my the two graphs intersect. So I'm going to be looking in that interval between negative 4 and 4. Now that I figured out that, now I've got to ask myself again, which is greater? Now I can't use my left endpoint and my right endpoint because at those 2 points, those functions are exactly equal to each other. So that's not going to tell me anything. So what I'm going to do is I'm going to pick a number that's between negative 4 and 4. And well, the one that I'll pick is x equals 0, because 0 is always nice and easy to work with. Well, when I put x equals 0 into my first equation, okay, I get that x squared, whoops, minus 9, I shouldn't write x squared, so I'm going to put in 0 for x. So y is equal to 0 squared minus 9, which is equal to negative 9, and that is less than 7. So what I know in this case, so y equals 7 is the greater function. So that one's going to come first in finding my area. So my area is going to equal the definite integral from negative 4 to 4 of 7 minus x squared minus 9 dx. Now then again, what I need to do is I have to simplify this down. Okay, so I'm going to distribute the negative inside the parentheses. Okay. And this becomes the definite integral from negative 4 to 4 of, I'll start with my variable, negative x squared, and then 7 plus 9 is 16 dx. Okay. So I'm going to go ahead and take the antiderivative. So I've got negative x to the 2 plus 1 over 2 plus 1. Plus 16 times x to the 0 plus 1 over 0 plus 1. And that's going to be evaluated from negative 4 to 4. Okay. So what that means is I've got negative 1/3 x cubed plus 16x. Okay. And I'm going to evaluate that expression at my limits of integration. So I'll start with x, oops. I'll start off with x equals 4. Okay. So I have negative 1/3 times 4 cubed plus 16 times 4. Okay. And so that gives me 4 cubed is 64. So this is negative 64 over 3. And then 16 times 4 is 64. Okay. And so I have negative 64 thirds plus 64 is going to, plus 60, is going to give me 42.667. Okay, I'll go ahead and round it to 3 decimal places. And then when x is equal to negative 4, I have negative 1/3 times negative 4 cubed plus 16 times negative 4. That's going to give me positive 64 over 3 minus 64. So that's going to give me a negative 42.667. So putting that into, let me finish writing this out. Okay. Putting this into, okay, my equation here. So I start with my upper limit of integration. So when x is equal to 4, I have 42.667. And then I subtract off my lower limit of integration, so negative 42.667. And when I add those two together, I get 85.334 as my area between the two curves.